Welcome to the first lecture of semester 2 physical chemistry. So in this lecture we will try to see the syllabus for the semester 2. Okay, so likewise in the previous semester there are 4 units: thermodynamics, quantum chemistry and chemical kinetics, and the last one is the electrochemistry. Okay, likewise same we are having like chemical thermodynamics, that is the extension of first unit in the semester 1. Then again quantum chemistry 2, that is again extension of quantum chemistry, and chemical kinetics, which is again a extension, and the third or the fourth unit, which is a application type unit, which consisting of a solid state chemistry and the phase equilibrium. Okay, so here we will see the some important applications of solid state and phase equilibrium in the physical chemistry. Okay, so first of all we will start with this quantum chemistry. So in quantum chemistry there are like important three parts are there. One is the rigid rotor. Okay, so in rigid rotor we will see this Schrodinger wave equation for this that spherical coordinates. Okay, in previous semester we have seen that for the Cartesian coordinate, that is x, y and z, but in this semester we will apply this wave equation in terms of spherical coordinates, that is r, theta and phi. Okay, r, theta and phi. So these three variables are there instead of our regular variables, that is x, y and z variables. Okay, so we'll try to obtain the wave equation for the rigid rotor. Then how that rigid rotor equation will tells you the various quantum numbers that we can obtain. Okay, so in previous semester we have obtained one that principal quantum number, and there we have stated that we can get the another quantum number, that azimuthal and spin or magnetic quantum number in the next semester. So we'll try to obtain that in the like various solutions of rigid rotor or the hydrogen atom. So second problem is the hydrogen atom problem, which is nothing but the two particle problem, because nucleus is there and the electron is there. So for this we can again obtain this RT and F equation, that is R is R equation, T means theta equation, and F equation is the phi equation. Okay, so based upon that we can get the actual shape of, means what is the shape of 1s, 2s, 2p, 3d, as such various orbitals, what is their radial probability, what is their uh, angular plots, radial plots. Okay, so all of these things are quite clear. So when we like derive that equations, we can actually see how that plots are obtained for 1s, 2s, 3s orbitals. Okay, and like in previous semester we have tried to plot the various wave functions. Likewise in this semester also we are having some non-instrumental practical based upon the shape of this 1s, 2s or 3s orbitals. Okay, so what is that actual shape of these orbitals, we can actually plot that by using certain mathematical equations. So the next important point is the various approximation, because these results which are obtained for the various wave equations like rigid rotor as well as for the hydrogen atom, which can be applicable for that specific system only, and if we want to like extend that for the real life problems, means higher atomic numbers, then we could not apply that wave functions for the more than two electron system. Okay, two electron system. So how we can like overcome that limitations, and what are the various approximate methods that we can use for the solving the wave equation, that we can see in the this approximation method. And last and most important part of this application of this quantum chemistry is the Huckel molecular orbital theory. Okay, so this HMO theory is useful for now this semester for the physical chemistry, and in the next semester you will get the like for organic chemistry specialization there, like pericyclic reactions are there, so there also you can again get some hints of this Huckel molecular orbital or HMO theory. And specifically we will see the ethylene 1,3-butadiene and benzene molecules. Okay, so we'll try to derive the Huckel molecular orbitals, their shapes and various parameters like radial probability or the distance, bond distance as such. Okay, so we'll try to derive that all parameter corresponds to the real atoms, okay, real life molecules. So this is the basic syllabus for this quantum chemistry. Okay? So other three units are like chemical kinetics, where we will try to mainly focus on the enzyme catalysis and the solid state reactions. Okay, so most of this syllabus is based upon this enzyme catalysis reaction. So what are the various factors which will affect the enzyme catalysis, that we will see. And one important point is the reaction in the solid state chemistry. Okay, so when we will try to start this unit, we can get into detail of this syllabus for that particular units. Okay, so this is the some introductory aspects. In the solid state, we like have to detail knowledge of our basic like Schottky defect or the Frankel defect, that type of defects. That defects are like zero dimensional defect. So again we will get to the some another type of defect which are 1D, 2D, 3D box, or the not box, 3D defects. And certain derivations are there in order to find out the number of defects. So we'll try to derive that equations. And again there is a one important aspect is the phase equilibria and various systems that like we have seen the water system or sulfur system in the like graduation syllabus. So in this semester we'll try to have the knowledge of our two component system or the three component system. So based upon that we'll get the knowledge of two or three component system. Previously we have seen the one component system, that is water or the sulfur system. Okay, and the first unit is the chemical thermodynamics. So the chemical thermodynamics is this more sort of a application part this semester. So it will be like fugacity or the for the real solution also we can get the various parameters, that is partial molar volume or the partial molar enthalpy. So that term will try to see in the details. And certain equations are there for the surface chemistry, so we'll try to derive that various equation. And last is the bioenergetics, so how that various biological processes involve the change in the thermodynamic parameter, that we'll see in the that points. Okay, so this is the overall syllabus that we are going to cover in this whole semester. Okay, so from next lecture onwards we'll first try to see this important unit, that is the quantum chemistry. Okay, so for this unit we'll require again this various basic terms like wave functions. What do you mean by wave functions? How will you solve that wave functions? And one important thing is that variable separation methods, how we have used that variable separation methods. Okay, so try to revise that variable separation method, because we'll thoroughly use this variable separation method for the solving this rigid rotor or the hydrogen atom problem, that is RT and F equations. Okay, so try to revise that previous things